afternoon to guests in Japan, and good morning everybody joining from the UK. As Alex said, my name is Margaret Tung and I lead on what we call economic diplomacy at the British Embassy in Tokyo. So what does that mean? Well, my portfolio covers quite a range of issues, including science and innovation, climate change, health, all subjects which today's event is very relevant to. I was really delighted to learn about this new Imperial College Transition to Zero Pollution initiative. I've always strongly believed in the value of bringing people together across different disciplines and sectors. To my mind, this is one of the most powerful ways to create innovation and real transformation. I almost said one of the simplest ways. Now, I understand that it's not always simple for people to communicate across sectors and to follow up on discussions, but I think in terms of the impact that you can have by bringing people together is really extremely significant. And in fact, it's part of my own work that I find very rewarding. The ability to convene people from different backgrounds, the requirement to translate things across boundaries, helping the UK and Japan to understand each other, finding new and effective ways to work together. That's something that I really enjoy. And I would like to congratulate Imperial College London on this initiative. And I'm really pleased that the embassy can be part of the launch event. Now, this bringing people together is powerful on any subject, but it's particularly important for tackling big issues such as pollution and climate change. As you may know, climate change is a key international priority for the UK, particularly as we prepare to host COP26 later in this year. Earlier this month, we announced our latest carbon budget, which will require the UK to reduce emissions by 78% on a 1990 baseline by 2035. This is genuinely a world-leading ambition, but it's going to be difficult. And it can only really be achieved by working with others to find the best policy, the best regulatory practice, the best innovation, and so on. And of course, industry has a vital role to play on issues such as achieving zero carbon and beyond that zero pollution. The UK is investing in green technologies such as offshore wind, hydrogen, zero emission vehicles, and so on, to produce what we think of as a green industrial revolution, in the same way that Japan's 2 trillion yen Green Innovation Fund will be supporting businesses committed to ambitious innovations over the next 10 years. And it's great to see the impact that industrial innovations can have on achieving net zero. So I saw recently an announcement of new recycling technology by Japan Rail Central, which enables the aluminium from recently retired Shinkansen trains to be reused in new bullet train cars, cutting carbon dioxide emissions by 97% compared to producing the material from scratch. So you can see the impact that can have on moving towards greener manufacturing and public transport systems. So for this reason, engaging with business is a really important aspect of our climate change work. We've seen a lot of leadership from business and industry, including in Japan, on encouraging governments to be more ambitious in their goals, in thinking about how innovation can lead a clean and resilient recovery from the impact of COVID, as well, of course, as actually producing products and services which support ordinary people's desires for a more sustainable lifestyle. So I'm really keen to hear more from the companies represented here today, their thoughts on how we can work together. To address problems such as climate change or pollution, which have social, technological, practical angles, it's vitally important to bring together, as this initiative does, scientists, engineers, clinicians, economists, policymakers, to pair research with entrepreneurship and industry to have the impact that it needs to have. Imperial College London has a very strong record of turning research into innovation, so perhaps it's not surprising that they're also thinking innovatively in launching initiatives such as this one. And of course, they also have very strong partnerships with a number of important and innovative Japanese businesses. So we'll soon be hearing about some of the latest Imperial research projects, ranging from real-time tracking of vehicle emissions to sustainable pavements. I'm really looking forward to those. And I hope that that session and the panel discussion afterwards will really inspire all of us on this seminar today to consider new ways in which the UK and Japan can work together on global issues such as climate change and pollution. So thanks very much to Imperial College. And I would like to thank and introduce the next speaker, Professor Mary Ryan, Professor of Materials Science and Nanotechnology and Vice Dean for Research in the Faculty of Engineering, who will be leading on this fantastic initiative as College Champion for the transition to zero pollution. Thank you very much.
Thank you very much, Margaret. That was a really nice and interesting introduction to our theme, and it's great to see so much enthusiasm with our partners and around the world for this initiative. And I think it speaks to the timeliness and the level of ambition that people want to see in moving beyond the climate crisis, hopefully in a positive way, but going on towards, I guess our vision is really to create a better future and see the climate crisis as an opportunity to rethink some of these challenges around pollution. So I've got a few slides that I'm going to share this morning just to give an overview of I guess, our thinking at Imperial around zero pollution and where we would like to go with this and how we would like all our partners to get involved. And then we're going to have some short videos around technology from Imperial College, and then a panel session with some of our partners from Japan and an academic from Imperial College. And we really would like the participants to get involved. You can post your questions in the Q&A, either as we go through the videos or while I'm speaking or during the Q&A. Please feel free to post your questions there. We will try and get through as many of them and hopefully have a really interesting discussion. So let me see if I can share my screen. First challenge. Host has disabled my screen sharing. So Alex or Nicola, I think the slide, if you've got the slides, could you put them up or let me share them? This is the problem of having an early morning meeting in London. No?
Hi, Mary. Sorry, we're just working on that.
Okay. Well, while you're doing that, I think I'll just start to speak to what we're trying to work on. The transition to zero pollution it's an initiative at Imperial College where we want to move towards both a resilient and sustainable society, thinking about, I guess, the multitude of challenges we have in creating a clean, sustainable future where we protect our environment, but we also protect the planet, we protect the resources, we protect the health of the citizens. And we need to do this by thinking holistically across all of the different challenges that we have in sustaining the society and the economy that we currently run. So this is the first initiative of Imperial College's new academic strategy, and it's a move where we want to look to the future, where we think, what are the really big challenges? And of course, the climate crisis is, I guess, the biggest challenge of our lifetime. And I say that even though we're still in the middle of a global pandemic, I still think the climate crisis is our biggest challenge. And the current pandemic, I think, has taught us an awful lot about working together across countries, working together as a global scientific community, and recognizing that we can do things quickly. We can actually make a difference on a scale and with a rapidity that we previously probably thought was not possible. The vision with Imperial is therefore to go beyond carbon. Zero carbon is our target, and you've heard from Margaret about the targets that have been set in many countries now. And Joe Biden last week recommitting the US to the Paris goals and beyond. But to go beyond the carbon crisis and to think about creating a future where we don't have unintended consequences. So when we fix carbon, we don't create other problems along the way. So for example, when we go to thinking about electrification of vehicles, we also think about all the other components that go into creating an electric vehicle, how we mine and recycle lithium, how we think about debris from car tires, how we think about usage of those cars. And what that means is we're looking at a really complex system, and we have to take a systems approach in thinking about all the different factors that combine that. And when I say systems approach, I mean that in almost a multidimensional way. So the technology systems, the materials and the resource systems, and then systems of different disciplines that need to come together. So we need to understand behavioral science, we need to understand economics, we need to think about business models. We need to think really carefully about policy and what different policy initiatives can do to, I guess, incentivize the right behavior. So I think I'm still not able to share my slides, so I'm just going to talk, and then we will share them with the panel later, so all the members so they can see. So we all know the challenge that we've got environmentally. You can find toxic metals in the Himalayan peaks, you can find plastic fibers in the deepest reaches of the ocean. Air pollution is currently killing more people, or contributing to the deaths of more people than the current pandemic. And CO2 levels are rising significantly above the levels we're going to need to meet Paris. So how do we bring together the right communities, the right people, and how do we make this transition a clean and sustainable one? How do we make this, if you like, the last transition? So obviously the scale of this is enormous, right? It's a huge, ambitious program that Imperial College is not going to do on our own. And what it means is we need a radical shift, and we need a radical shift in our economic systems and in our industrial systems. We need a radical shift in business models, but also we need that to be underpinned by innovative policies and governance structures. We all need to work together. I think Margaret's words around bringing people together is really critical to what we see as being important here. We need to think about the entire system and the life cycle. So what do we want to do at Imperial? What do we want the transition to zero pollution to do? And I guess we want to think about fostering a systems thinking model. We want to bring together discovery science, transformational, cross-disciplinary research, technology and innovation to create and translate. So it's not just about creating them, we need to deploy all these solutions, and we need to deploy them rapidly to pollution in all its forms. So we're trying to bring together and build new partnerships that converge disciplines from fundamental science, engineering, systems thinking, and policy. And I guess one thing that we want to do, so we're obviously a research organization and an innovation organization, but we're also an educational organization. And we want to be able to make sure that the graduates of Imperial College have this holistic mindset instilled amongst them. So we want to create graduates that are both imaginative. They need to have the freedom to imagine what the future can look like. They need to have the skills to deliver it. And I think we need to have graduates that have an obligation to question what we're doing and to question how we are creating technologies of the future, because they have been thinking about the consequences that we've had from previous technologies. So we're working together with all our key stakeholders to try and make sure that this educational and research program is enabled and translated. We had our official launch event at Imperial College in September of last year, and Mary Robinson very kindly gave our keynote speech. And I just like to give you a quote of hers, because I think she captured quite beautifully what we want to do. And as she said, the transition to zero pollution represents the great redesign. Zero pollution is timely and a valuable holistic concept to guide policymakers as the world tries to develop a viable and sustainable post-pandemic recovery. And this idea of the great redesign, I think, is what we really are talking about, creating a new future that is sustainable. So we have a framework where we want to build our research, and it crosses, I guess, 4 pillars, all with this zero pollution systems lens. So an economic stream, a technology stream, a stream where we're looking at the interconnectedness of the water, food and energy nexus, and that's really how we live, I guess, in urban environments, and that's becoming more and more critical across the globe. And then looking at environmental and human health impacts of pollution. And of course, they don't exist in silos. The whole point of our program is to try and de-silo all of the different aspects of technology and policy. So to do this, it's not a problem for Imperial College. It's not even a problem just for the UK. It's a global problem. We all recognize this. So international collaboration is a key aspect of what we're trying to deliver here, which is why we're really delighted to be talking with our friends and colleagues in Japan, and that lots of people have joined up to come and talk with us today. we're looking forward to building these links further. And please do get in touch with us. We will share these slides so people have all our contact details. And we're really looking forward to both this event and to working together in the future. Thank you. And Nicola, maybe if you can share the slides which just highlight some of those comments, I think we'll be able to reach back to them. Hopefully I gave you a flavour of the kind of things we're thinking about and the challenges we're facing.
That's great, Mary, thank you. Yeah, I've made you the host now, so okay. If you could possibly play the videos from the link, that would be okay. Fantastic.
I can do that. All right. No, I can't access that, Nicola. It says I need permission. So you should take back hosting and play them. That's fine. And it's nice to see we're already getting some questions into the Q&A function. So please keep those coming. Hopefully we will get around to discussing them later.
Sorry about this.
I think one thing I'm going to prime our panelists with a question in advance, because it's something that's been vexing me somewhat as a material scientist, and that's this balance of, I guess, resource protection and planet protection. A lot of our sustainable future relies on us sensibly utilizing the materials resource and thinking about materials from extraction to recycling and the life cycle of that. But also, I think changing our perception of what it means to be allowed to pollute, right? So previously we would treat the earth, the atmosphere and the ocean almost as an infinite sink, right? And that pollution didn't matter until it got to a threshold level. And every time we did that, we realized that we don't know what the threshold levels are. And we then end up with a massively distributed resource / pollutant that we can't recover. So how do we think about, I guess, this concept of holding both resource protection and planet protection at the same time actually requires, I guess, a big mental shift. And is that, how do we deploy that mental shift of looking after resources and looking after the planet and creating these, I guess, circular life cycles that are sustainable? Have you got it, Nicola?
Mary, would there be any possibility to do the panel discussion now and play the videos afterwards?
I think we can do that.
Would that be possible?
We can maybe even have a break between the panel. All right, so let's move on to the panel.
Sorry about that, everyone. I'm
gonna come to each of our panelists in turn, and if you could just briefly introduce yourselves, and then maybe just take a couple of minutes to say what you think the big challenge for your own organizations are, and how this particular initiative and these concepts, this framework that we've been talking about, links to your own challenges and your own ambitions for your organizations. So if I could come first to Dr. Norihiro Suzuki from Hitachi. Good evening, Suzuki-san. You're on mute at the moment, so if you could unmute yourself and welcome. Thank you very much for joining us. Oh, I think you're still on mute.
Okay.
Good.
Okay, thank you. So I'd like to thank you for the opportunity to speak today. So my name is Norihiro Suzuki, CTO of Hitachi. So Hitachi is a global company with over 320,000 employees worldwide. So we believe as a company and as individual, that is our mission to contribute to society through technology. As a company, we are pursuing what we call social innovation business and enhancing societal infrastructure using digital technology to maximize environmental, economic, and social value. Speaking for myself, I believe that zero pollution covers not just the CO2, but many forms of local and global emissions, waste, negative byproduct, impact, etc. So as a Hitachi, so we consider zero pollution to be an important part of achieving a sustainable society. And we have made a commitment to be carbon neutral by 2030. So we believe that business needs to contribute to achieving Sustainable Development Goal 12. That is responsible consumption and production. So responsible production means that producers do not just supply product to consumer, but they also assume some positive responsibility for the impact that their product may cause on the environment throughout their entire life cycle. This is how Hitachi considers transition to zero pollution, and we are pursuing this goal through internal initiative and through our business activities. So we believe that as a manufacturer, so we have a responsibility to society to reduce, if not eliminate, waste. And it's something we have been doing since the early 1990s, for example, recycling industrial product and other materials. So while these efforts are important, we now need to scale our efforts. The challenge for Hitachi in the future will be to think collectively about not just our own activity, but also the use of water and other resources by suppliers and customers, and to offer ways of reducing or recycling, and then to work together to put them into practice. So we are also developing the technologies needed for recycling to be adopted more widely as a business model, including technology for advanced assembly, sorting, refurbishment, remanufacturing, and sensing. So in terms of impact through our business, so last year, so we acquired the ABB Power Division, the biggest transmission and distribution company for electricity, and established Hitachi Astemo to contribute to an electrical vehicle society. So our aim is to apply our digital technology to social infrastructure to maximize value, as well as strengthen our position to maximize impact and make a real difference in the global climate change challenge. In short, for business, we are focusing on the area that will have the highest impact on global emissions, transport through rail and EVs, energy generation and management through grid solutions for increased renewables, and decarbonization industry using low or zero carbon hydrogen. So however, the activity towards zero pollution cannot be carried out by one company or one institution alone, and the collaborative creation with other companies, universities, government, and communities are essential. Hitachi is also collaborating with the university around the world, including with Imperial College in the UK, on grid control when introducing renewable energy through wind power. That is the current measure of our activity in Hitachi. Thank you.
Thank you very much. And I already have lots of questions about that follow-up, so I think there's going to be some interesting discussion. And please, if you're listening, I'm sure lots of our attendees also have some questions on how we're going to achieve that. But it's really wonderful to see such big ambitions and commitment. So our second panelist from Mitsubishi Heavy Industries is Dr. Fumiko Takai. If you could maybe introduce yourself, also just say something about how your own company and the challenges that you're facing, obviously different. We recognize that there are different but linked challenges across different organizations, and I guess what we're trying to do here is find some common ground and common principles where we know we can work together. So if I could hand over to you, Takai-san. Oh, I think you're on mute.
Hello? Can you hear me?
Yes, we can. Thank you.
Thank you. Thank you for your giving me such a great opportunity to speak in the panel. I'm Eisaku Ito, the CTO of Mitsubishi Heavy Industries. Mitsubishi Heavy Industries are one of the conglomerate company and manufacturer for the critical infrastructure and products for the space and the sea and on land and air. So we have a very wide range of the products, including the self-defense product. And we are working for especially the energy transition. That is one of the very important activity for the zero pollution activities. And energy transition include the power generation. For example, the transition from the fossil fuel power generation to the renewable energy and or the hydrogen ammonia fueled products. And also we are working for the grid stability with a higher variable renewable energy ratio. And that means in each country, with a higher variable renewable energy, the demand response very important. And also the supply, we have to supply the demand balancing of the power and energy consumption. So that means the integrated control between the centralized units and the distributed systems are required. And also we are the leading company in the world of the carbon capture and utilization. So that is one of the big area, especially the challenging area for the technology development. For example, after the carbon capture, not only storage, but the utilization is important. So that is other specialty, material science is very important. For example, some catalysis to change the CO2 to the more variable species. And also the circulation economy is one of the big area which we are now challenging. That is resource protection and pollution reduction and waste reduction. And we are working for reducing the material, recycling material, and reducing material. So that is it's easy to say the reducing or recycling material, but it's very difficult because we are working for example, the critical infrastructure like a power generation, including a nuclear power plant. In that case, some kind of the quality assurance is very important. After we recycling some material, because some contamination is sometimes very key factor and a key impact on the reliability of the material of the designed parts or products. So that is a very important issue, as well as the economic values. And also optimization of the operation is very important because the more efficient operation of the power plant or some plants or machines, that is the connected to the reduction of materials. So it's very important. And also the important thing is some kind of the safety issues. For example, the fumes of the recycling or remelting the materials or something, that is one of the another issues. And as for the operating optimization, IT and ICT or AI technology are now already adopted, especially even for the very complicated critical plants. So such a emerging technologies like AI is very important for the operation optimization of the operation. And as for the energy transition, another energy transition, the zero pollution. I think one of the difficult issue is the social cost reduction. So such a society, sometimes, for example, the carbon neutral society, if we adopt the renewable energies increasing more and more, then that leads to for example, the cost of electricity will become maybe twice because variable renewable energy requires some kind of the volume of absorbing the variation of the energy creation. That means that we have the twice of the plant capacity. So easily we can imagine that the cost of electricity will become twice compared to the current electricity cost. So the social cost issue is very important. So such a zero pollution energy, carbon neutral, such a society, it's very difficult. And but we have to work and cooperate for aiming such a reduced the total social cost realizations. Thank you.
Thank you very much, Ito-san. And I apologize. I was expecting you, but then you came up with somebody else on my screen, so I was very confused. But I'm very happy that you're here. Lovely to see you.
No problem.
And thank you for that really thoughtful introduction. And I think you really highlighted many technological challenges that we are facing, but also an ambition to solve them and to solve them together. And just at the end, touching there on, I guess, the social contract and the importance that we create a just transition. So people are able to we want people to be able and willing to make the right choices and to bring society with us. So that's really interesting. So I'll just move to the last of our panelists, who's Professor Ricardo Martinez-Boas from Imperial College London, who's a professor of mechanical engineering. So Ricardo, I guess it's a slightly different question for you in that, how do you think that the research that you're doing and that academics in general are doing can really help us bring about some of these transitions and, I guess, deliver the translated technology as well as fundamental understanding of some of the challenges?
Thank you, Mary. Thank you, Margaret. And it's great to be in this panel and join you in the afternoon in Japan and very early in the morning in London. First of all, I'm a professor at Imperial. I've been 25 years, or nearly 26 years at the college. My area of research is on transportation, so most of my comments will end up being either transportation or waste heat recovery, two areas that I deal with. I am very much familiar with air quality impacts. Just to give you an outline, I was the government advisor of the Volkswagen scandal for the UK, so I'm pretty much familiar with the impact of in our cities. So number one, zero air quality impact. It's neither towards nor is maybe, it is zero air quality impact. Unacceptable level of pollution in our cities are even in the pandemic, although they've gone down, are just not acceptable. So we've got to turn towards fast, rapid deployment of air quality in our cities, where urbanization is such a large proportion of the planet. And number two, of course, anything to do with net zero carbon fuel deployment. I'll mention that later if allowed. I think that that need is ever more important today. There are some areas in transport, some areas in production that cannot be decarbonized at source. They'll need to have a net zero carbon cycles. I'd say you asked me a question, Mary, about the college. Well, there's three things come to mind. One, allow us to do curiosity-driven research. Much of our research is at the early stage, and some of our researchers, of brilliancy of our researchers, need to have the freedom to explore blue skies ideas. Two is about people. I mean, the college is about people. I mean, people is the centerpiece of what we do. And I'll bring in a sentence that probably won't be discussed today. I think we need to create undergraduates, postgraduates that can reinvent themselves. It isn't about the traditional policy, the traditional learning. We need to reinvent. They'll have to change in the time frame of the career. And I wonder whether we are allowing our undergraduates and postgraduates to reinvent themselves in a few years. Just in 5 years, they might have to reinvent themselves. And finally, translation. Most of what I do is application-based. I work a long-term partnership with Japan, at least on one center with MHI and others. I believe in this translation. No translation, no benefit. So I'm very strongly minded towards translation. Those are the key areas I wanted to mention, Mary. You've done the rest for the college strategy. So.
Okay. Thank you. And I think I fundamentally agree with you. We need to be creating the right people. And I think that ties into what industry are going to need. So they need also to be, pushing organizations like ours to create the kind of graduates that they need to enable the transformation. So I think at this point, we're going to try, and hopefully the technology will allow us to show some of the videos that we were planning to see, and then we'll come back and we'll have some questions for the panel. So Alex, do you want to try? But I'm completely confident that we can spend the next 3 hours talking about this if we need to. So I can't hear the sound on that, Alex. I can see Anthony speaking, but there's no volume. No. Slightly disturbing to see that you've got a photograph of me on your desktop there, Alex. No. Okay, well, let's just have a really interesting Q&A discussion. I think we've got plenty to talk about. And I think let's start. And I think I'm probably going to come back to you, Ricardo, first, because we have a Q&A about, is there a future for the internal combustion engine? And I think and just listening to also Ita-san talking about CCS, we know that there are we want to try to decarbonize transport, all right? It's a key goal for all governments, but there are some aspects of transport that are particularly hard to decarbonize. We've got aircraft, heavy vehicles. Can we get to a decarbonized or electrified transport network, or do we need the internal combustion engine at some point with CCS technologies? And can we think about what's the short term? What should we be aiming for? We've got 2030, 2035 targets. And what's the long-term endpoint, do we think, for these different types of technologies? All
right. No, thank you for that. That a very pertinent question. So I think nothing, there's no silver bullet, and this is a classic, thing one can say in a panel. But let me spell it out. In cities, zero pollution means zero pollution. It means no internal combustion engine running on our cities unless the internal combustion engine has zero outlet, which is unlikely to happen. We can enable, perhaps outside cities, the picture is slightly different, where pollution impact is somewhat of a lesser importance. That's one thing I would say. I say, road transport, if it's aimed to pure electrification, in itself is a nice objective to have. In reality, it is making the life of the battery deployment, vehicle deployment harder. So let's have a parallel program, as the governments have, on net zero carbon fuels. These are fuels which are created synthetically through renewable sources, through carbon capture, of course, through CO2 capture and hydrogen produced through renewable sources that enables a synthesized molecule. Then to be truly net zero carbon. Nothing else will do, in my mind. And then those net zero carbon molecules will be used in the most difficult environments, like air travel, like long distance travel. And they'll need catalyst systems in any case, because they produce NOx, as you know. So there is a place for that kind of internal combustion engine, using net zero carbon fuel with zero tailpipe NOx due to catalyst systems. So I can see that happening, and I think a single broad brush, and this is a strong statement maybe from someone who knows a bit about this, a broad brush on pure electrification is not a correct answer. The answer is a mixture of technologies, but in our cities, net zero pollution, and outside our cities, net zero carbon, as well as having little impact in the vicinity of that transportation. So I would say electrification is not a pure answer. It's a mixture of electrification, net zero carbon fuels attached to carbon sequestration. I can't hear you, Mary. I think you're on mute, Mary.
I don't know. So, Ito-san, I'm going to come to you next. Well, first of all, if you agree with Ricardo or that position, but also when you talked a little bit about CCUS and where are the big challenges to creating sustainable fuels, I guess, from your perspective?
At first, especially for the transportation, the zero emission, zero pollution is a very challenging. I think two options can be selected. One is the EV, right? The electric vehicle. And problem is where is electricity coming from? So that electricity can be generated as a renewable energy, or the fossil energy, or nuclear power plant, and solar panel, or so that original energy source is very important. That is one issue. And second option is, for example, the hydrogen. That is a clean energy, clean fuel. But again, the issue is the where from that hydrogen coming from. So even you utilize the renewable energy and maybe the water electrolysis by using the renewable energy. But for that efficiency, the generation efficiency is about 80%. And if you utilize that means the hydrogen already lost 20% energy. And if you use the hydrogen for the combustion engine or some other, if the combustion engine, the efficiency is, for example, 50%, that is a very challenging target. Then the 0.8 times 0.5, that is maybe 40%. Total efficiency is 40%. That means hydrogen is, in another word, the hydrogen is a 40% return efficiency battery, right? So that is one of the very important key issue. So the total energy efficiency or total social cost is a very issue. And so that is the one important reality. And the second one is more so for the transportation, for example, so the catalysis or many material technology is important. And for example, the fuel cell is another option by using hydrogen, for example, and fuel cell is one of the possibility because actually we are the manufacturer of the solid oxide fuel cell, and that is theoretically that can be used for the generation of the hydrogen. So the reverse operation is possible. So that is one of the very interesting the products that can be used. And that is the second point. And finally, the third point is carbon capture and utilization. So that is a very big possibility by using the CO2 can become the very useful material like ethylene or the methanol or the maybe methane or some other products or the carbon black maybe. And but the key issue is some total energy consumption. Because the CO2 is the carbon plus O2, so the combustion result is the CO2. That is the energy, we utilize that energy. But CO2 utilization, we need at least the same amount of energy. So that is the key issue. But sometimes such a carbon utilization issue, such a very simple but macroscopic energy balance can be neglected. Sometimes, not sometimes, I can say almost all times that is neglected. So maybe the academia and engineer should be, how to say, speak up that reality with a more loud voice.
Yeah, no, I agree, and I think it's an interesting perspective. And John had asked in the Q&A also about hydrogen. I think you've answered some of those questions. But I think there is, and this is where we want, I think, TZP to change people's perceptions, because if you did just look at efficiency or the baseline thermodynamics, you wouldn't think about deploying some of these technologies. But then when you start to look at the bigger picture, right, and you know, some of the environmental challenges of battery technology might well outweigh the efficiency loss in hydrogen. And how do we think about ways to measure those different things to work out what is the most sustainable mix, I guess, because in all of this, we're going to be looking at mixes of technologies. So can I come to you, Suzuki-san, and from your perspective, where we sit on the internal combustion engine, and of course, I know you're now also with ABB thinking about grid supply of electricity and the big challenge if everybody suddenly has an electric vehicle, how do we manage that transition as well is also an issue for you more generally.
Yeah, so for the transportation, I think that so the digital electrification, material, and the energy hydrogen related technology is actually, this is a key part. And for the railways, so we are promoting a further energy saving by converting part of the existing diesel drive to a storage battery in sections that are not electrified. So that is a short-term solution, but in the long term, hydrogen is a key technology. So we are developing a hydrogen rolling stock with Toyota, so utilizing their the hydrogen technology. That is one of the solutions for the long-term, solution for the zero carbon for the transportation system. And for the electric vehicle area, so for a commercial fleet, so we are working to build an end-to-end service to improve productivity, so as well as reduce the environmental impact, including a vehicle utilization, maintenance and repair, workforce management, EV charging, battery and vehicle optimization. So we actually preparing participating in Optimized Prime, which is an industry-led network innovation competition, NIC funded project to look at the effect of commercial EV on the electricity distribution network. So IoT technology is being used to analyze the charging activity of up to 3,000 commercial vehicles. The data will help us to understand the benefit of and where, when, and how much power people will need when EVs are fully introduced into society. So this kind of the IoT technology is very critical to promote this kind of the EV sort of the society. From the viewpoint of the reduce, reuse, and the recycle, so battery technology is actually very key. So renewing the battery technology and also renewing the component used in the cars. Of course, the use of the rare metals. So this kind of the material technology is the sort of the innovation of the sort of making the zero carbon society. So we closely work together with the university and the research institutes to make it this kind of the innovation. So for sort of the from sustainable society, that is the current activity for us.
Okay. Thank you. And I'm going to stay with you, Suzuki-san. I'm afraid I'm going to put you on the spot again, because in your introductory, you talked a little bit about responsibility of corporations for the technologies that they produce through the life cycle. And I think there's a really interesting change in how we think about ownership models and how we think about who has responsibility. I guess just from I guess a Hitachi perspective, how are you trying to do that? What are the challenges? And then where do you think policy and government action could help in deliver that? Or is this something that we think should become an obligation, a legal obligation? Or is it something that you think is part of your social contract and gives you some advantage anyway?
Yeah, so covering the total life cycle of the product is very essential for Hitachi. Mm. So as I mentioned, so we have some sort of the trials. So for example, recycling of household appliance by the Tokyo EcoCycle company of Hitachi. Mm-hmm. And also the use of the rare earth metals used in the ATMs, and also renewing component used in construction equipment and cars. And of course, renewing the battery and the desalination plant to enable the use of seawater in Saudi Arabia and South Africa. This is just an example of our contribution to a sustainable society that is responsible for Hitachi. So maintaining the sort of life cycle of the product, sort of the life cycle.
And do you think this is something that ought to be mandated? Do you think a change in policy is needed to make more industries deliver this kind of mindset and this, or do you think it's something that the industries that are doing it will become successful because they're doing it? And will that be fast enough?
Yeah, so actually we are sort of responsible for all the value chain, from the material to the consumer's side. So we are now focusing on our sort of the productizing, so factory and delivery side. That is the sort of current focus. But actually, so our product uses other suppliers' material, other suppliers' components. So in total, so value chain, we need to taking care of it, and we sort of contribute to the sort of the virtuous cycle.
Yeah.
That is sort of our next challenge.
Okay. So Ricardo, if I could just come to you on a version of this question. So you talked a little bit about air pollution and the criticality of that. And I guess there's a difference between the way we treat different polluters, right? So, you know, the nuclear industry is responsible for its nuclear waste. Other polluters are not held with the same degree of accountability. And do you think there's a requirement for policy changes and to really deliver the kind of clean environments? Beyond technologies, do we need policy to drive translation?
I think so. I think having been involved in transport policy, I think it's a joint thinking, right? It's not one government. If it's not one department, it's not one government. It is a multi-government approach. It is clearly the policy is sometimes lopsided against some particular industries, and one of which is road transportation for evident reasons of air quality and health impact. But you know, road transport, air transport gets away with some stuff that shouldn't, and I think policy has to change. I mean, policymakers are in themselves need to innovate, you know, and I think there's reluctance to do so. So I think they need to step up. You mentioned nuclear, you mentioned waste, you mentioned recycle. They need to step up to curtail most of this, and rather than putting so much emphasis on one item and somewhat forgetting the other massive items of pollution, non-emission related.
Yeah. Do you think, and where do you think the responsibility should lie, or do we all need a little bit of it? Because I think right now there's a, you know, is it the consumer, is it the producer, is it the government, is it a mix of those and other? And I know you're not working on policy per se, you're working on the technology end of that policy drives. But where are the specific innovations, and how I guess it's around behavior change from the individual to the global level?
You're absolutely sorry, Mary. I think behavior, we have to get accustomed to some change in behavior. So I do not leave the home. You're in my home with this video, and welcome to my home. And I don't have to travel, right? Now I've changed my behavior due to the pandemic forcing me, but rest assured, neither the level of travel nor the cost of travel will be maintained as we have seen it. So therefore, behavior change is needed. Let me give you an example of where behavior must be helped. If I want to travel from here to the northern part of England, I'm going to get out on the street, get into the bus, or then eventually get into the train, underground to train to destination to the locality I really wanted to go. There are many transitions, and these are not seamless transitions. So one little example I give you, Mary, is that behavior can change if we make the customer experience such that it is acceptable. Policy will not be able to force that transition unless we make customer experience acceptable. And I can go to Edinburgh, well, now in Scotland, in a seamless fashion with a single ticket on my mobile phone and with everything being available to me as I travel. So that is a behavior change which is imposed by some degree of technology, but mostly through policy, not by forcing change. That's one example I give you. The other one I give you, and I'll do it very quickly, we're short of time, is that if you're thinking about vehicle development, we're always thinking of, I should think of 3 attributes. I've spoken publicly about this. 1, they need to be affordable. So you don't come up with technology that is not affordable to the customer. 2, needs to be sustainable and clean. But the third one, we forget, it needs to be likable. Affordable, sustainable, and likable. I need to feel good in that vehicle. That's another little example that our partners, currently in the panel, need to think about. It isn't about forcing policy. It is about making it likable, making it sustainable, and making it affordable. And then we carry the people with us. And that all takes effort and policy.
Okay, thank you. So Ita-san, we're getting lots of questions and comments about CCS, and I know that you're really innovating in this space. And I guess the question really is around the ability of CCS to, or I guess the question is framed almost in isolation, will CCS allow us to keep CO2 at the right level below the targets? And how do we monitor what's going on in those systems?
Yeah, that is the CCS is very promising technology and already working in some chemical plants. That is they are utilizing the CO2, the collected CO2, and we are working for developing the more efficient CCS and CCU system. CCS is some issue is the location of the storage. So the typically underground, the enhancement of the oil recovery, that is a very typical way, but maybe the storage is a very difficult because we have to compress the CO2 and put into the underground, for example. So that is, again, the energy consumption is very huge. So I think the more in near future, so the utilization is much affordable and the promising technology.
I muted myself again. Suzuki-san, I think we have a question in the chat, and it just relates to, I guess, this last question we've been talking about how we use objects and items, and are you considering thinking about, or have you considered different types of models? So the ownership is maintained by the company that creates an object or something to use, and the consumer just pays to use it. So we completely change, I guess, that transition of ownership to the consumer, and it's a pay to use type model. Is that something that you think is part of the future, where we change? It's basically talking about changing consumption behavior, but also fundamental business models.
Yeah, so the customer behavior is actually very important. If we take the circular economy, so as an example, what is needed is to make that transition away from the era of high resource consumption and toward one in which recycling allows people to coexist sustainably with nature. So to think about this way, so we Hitachi have found that in order to focus on the goal, it is useful to backcast from a vision of the ideal future to understand the problem that really need to be solved and what the real opportunities are. To facilitate this process, Hitachi has developed a co-creation approach we call Nexperience that promote the development of business model and solutions through consensus building. That is pretty related to a customer behavior. So from the viewpoint of the customers, we think about what the future should be. So based on this future ideal, so vision of the ideal future. So we discussed with the residents in the city. So through some discussion, we laid that the mindset of the quality of life. So for the so this kind of the discussion is very critical to make this a sustainable society in the city.
Thank you. So I guess just to come back to a little bit about these global ideas and thinking about partnerships. So both the UK and Japan have now committed to quite serious climate targets. What do you think the role for international collaboration is, and in particular, where can the UK and Japan, which have very different economies and different societies, but where are the commonalities where we should be working together? So Suzuki-san, if you go first.
Yeah, so UK and Japan have many similarities. So being island nations, I think therefore there are many areas that two countries can work together. establish commonalities in the technology and solution. But the decarbonization is a common issue, not just for the UK and Japan. So it is not something that can be achieved by one country or one industry. It is a goal toward which the entire world should head in the same direction, and all sectors should make a concerted effort to tackle. So as the host country of the COP26, I expect that UK will play a leading role in this area. And as a Japanese company, I hope that Japan government will take a leadership role in international cooperation for decarbonization. So this is sort of our expectation to COP26.
Yeah, well,
We are proud to.
I hope you are right. I hope you are right. Iko-san, maybe could you give us an idea of where you think, I guess personally, and then from your corporate perspective, where are the international partnerships that you think and the international challenges where we need to work together?
Yeah, I think the UK is one of the leading countries which is increasing the renewable energy and innovation technology development in academia. So Japan is leading the development and implementation of advanced technologies, products, and infrastructures. So, for example, in the UK, grid resilience is highly required due to higher variable renewable energy ratio in the isolated small island. So the Japanese manufacturer supplies the high response, for example, the gas turbine, and into the UK, and such a product capability also very well cooperated with the grid regulation in the UK. I think this is a very good example, and in terms of the collaboration, such a social system collaboration, as well as some technology development collaboration is very important. So I think such an innovative and disruptive technology development should be done in the collaboration with several countries. Especially, I think traditionally the collaboration between UK and Japan is working very well. So I think such a more we should encourage such a collaboration, the technology development in between the academia and the industry.
Okay, thank you. Ricardo, from your perspective, how do you see global collaboration being? I guess we all say that we need it, right? We recognize this is a global crisis. Are there opportunities and barriers to kind of delivering the collaboration that we need at the academic level and of course the translation level, which you highlighted earlier?
Yeah, so really it's all happening, Mary. It's happening. We work with Japan, Japan works with us. We do research at the college of the highest level of quality. We translate it into products. I have a particular deployment in a particular product of MHI running currently in vehicles. This is translation. But what I wanted to emphasize, and I don't like headlines, but I'm going to use another one. The pandemic has taught me, and I'm trying to translate this to our partners in Japan, it's taught me that we need rapid reaction to challenges. And it's not my words. Rob Miller at Cambridge, a good friend and collaborator, gave me that sentence, but I've adapted it to myself. Rapid reaction is the answer. We are far too slow in reacting to global challenges. And I think teams of flexible, mixed with industry, government, and academia, which formed and deformed in a positive sense to tackle a particular global challenge. I think our companies, collaborators are often too slow to do that. So I encourage rapid reaction.
What do you think needs to happen to enable that? I mean, is it just a mindset that actually now we recognize we can do it and we thought it was too hard before?
I think it kind of often in companies, in college, we know how we do it. We get clever people working together multi-departmentally and multidiscipline. But in companies, you need the top to instill this ability to create teams across manufacture, AI, materials, thermodynamics, fluid mechanics. They come together for a challenge, and you give them the freedom to act. And then they have the resources and freedom to act. Then they solve a problem, maybe the ventilator problem. Let's just be very specific. And then that, once done, they demand, they go back to their team. And that flexible thinking is somewhat alien to big corporations of the type we are familiar with, in certainly my subject area. So I encourage, it's a thinking supported from the top down to enable teams to act freely without encumbering them with blaming. No, they come, and I'm really excited about this idea. From the pandemic, I'm writing a piece on this topic. Rapid reaction is the answer.
I agree, and it's needed right now. Okay, so we've remarkably only got 2 minutes left in our allotted time, and I apologize, we're not going to get to all the questions. So there's lots of interesting questions about resource availability for the transition, and chemical pollution and how we deal with all of that. So we might have to have a follow-up where we continue this conversation, because it's been really interesting. But maybe if each of you just give a very quick 30-second what your aspiration for the future, a sustainable future is, and how we can really embed the zero pollution mindset. Ricardo, if you go first.
Well, I'm just excited about the program you lead in the college. What can I say? Look it up. Those who are in the audience, look it up. Look at what Mary's trying to do for the college. I'm excited about the flexible education. I'm excited about creating people who can deploy themselves in that manner in companies. And I'm excited about solving a problem that is absolutely fundamental. We cannot afford a day go by without solving some of these key issues. I'll leave it like that. I've spoken too much.
Ito-san, some final words?
Yeah, thank you for the very interesting discussion. I think that I like the curiosity-driven innovation, and maybe we can connect with such a curiosity to the necessity of the society and a very big issue we can tackle and challenge such a to solve the very difficult issues. Thank you.
Thank you. And Suzuki-san, I'm going to give you the last word on your aspirations for the zero pollution.
Yeah, thank you. So collaboration across countries and sectors is necessary. And Japanese government institutions and the companies are actively and sincerely working on these issues. So among the many issues in society, so Hitachi is particularly focused on solving environmental problems, which is in line with the UK government's goals. So Hitachi believes that we can contribute to the UK's decarbonization in the area of railway and automotives. So I want to continue to collaborate with Imperial College of London. Thank you very much.
Thank you very much. And I'd like to really thank all our panelists and all the attendees for joining us this evening. I think it's been a really interesting, stimulating discussion. I'm really looking forward to having further conversations and developing these partnerships. Alex has put some links in the chat. If you want to learn more about the program or get in touch, please do. And we'll also share the videos that we were unfortunately unable to share this morning, but actually I think it allowed us to have a longer, more in-depth discussion. So I don't think that was too bad a thing. So thank you all, and have a good evening, good day, and I look forward to meeting you all again. Thanks.
Thank you.